The properties of integer multiplication are pretty much the same as all the properties you've seen before, so I'm going to run through them very quickly because this really is a repeat of information you should already know. So for integers, the same properties hold that held for whole numbers. The closure property. If you take two integers and you multiply them, you get a unique integer, right? A times B will also be an integer. That's the closure property. The commutative property means if the order changes, you still get the same answer. A times B is the same thing as B times A. The associative property is the one where the parentheses move. So if you multiply A times B first, then multiply by C, that's the same thing as multiplying B times C first, then multiplying by A. Notice the order is the same, A, B, C. The parentheses just moved. And as long as it's all multiplication, you'll get the same answer. These two are the distributive property. There's one for addition, one for subtraction. They're essentially the same thing. So if you have a number multiplied by a sum that's in parentheses, you can distribute this number by multiplication to each piece. So you can do A times B plus, you'll still have a sum, A times C. And you've probably seen it written like that with the little arches. Or if you have a number times a difference, you'll do A times B minus A times C. So please understand that this addition stays, the subtraction stays. It's just we've removed the parentheses, and so that's a way to simplify. And if you do this process backwards, it's called factoring. The identity property. What number could you multiply A by to retain A's identity? Well, if you multiply by 1, the number doesn't change. So the multiplicative identity is the number 1. A times 1 is the same thing as 1 times A, and it's just A. So multiplying by 1 doesn't do anything, essentially. And then the zero property says that if you multiply by 0, you get 0. So multiplying by 0 will zero everything out. These last three, if you take a negative 1 times A, that's basically the same thing as negative A. So meaning you don't really have to write the 1. A negative A is negative A, right? It's like you made an opposite. Negative A times B, notice the parentheses are just around the B, but you could also loop in the A into the parentheses and it would still be negative. So negative A times B is negative A times B. Like, as long as the negative is in there, it could be out in the front or it could be in the parentheses or outside of the parentheses. As long as it's in there once, it's the same thing. And then this one says, if you take a negative A times a negative B, the answer is actually positive. This is reminding you that two negatives, when you multiply, make a positive. So for the examples, they want us to simplify so that no parentheses remain. So it's like a simpler version if you don't have any parentheses. Another way to say that is they want us to distribute, because distributing will get rid of the parentheses. So for this first one, what we're going to do, see how you have a number in front of the parentheses? So the fact that between the 5 and the parenthesis there's nothing written, the implication is that that's multiplication. So we're going to distribute negative 5. So negative 5 is going to get distributed to each piece. When you distribute negative 5 to the first piece, you just get negative 5x. And then when you distribute negative 5 to the second piece, it's negative 5 times a positive 2. Well, that's going to be a minus 10. So you can see I no longer have parentheses, so I did what they asked. And the x got multiplied by negative 5, and so did the 2. And so this, you see how the numbers in the parentheses were positive? When you multiply them by a negative, now both of those terms become negative. On the next one, what we're going to distribute is the negative 6. So the negative 6 is going to get multiplied by the x, making negative 6x. And then the negative 6 is going to get multiplied by a negative 3. Well, two negatives make a positive. That's going to be plus 18. So if you look in parentheses, so you see how it was a positive and then a minus? Now it's a minus, then a plus. So that negative 6, it changed the signs of everything on the inside. It made them the opposite. And then for this last one, we have 2 pieces times 2 pieces. So we have a lot of distributing that has to happen here. The x has to get distributed to the x minus 2, and the 3 has to get distributed. So we're going to do both of these. Let's see, I'm going to do this in some colors here. First, I'm going to distribute the x to each guy over here. So x times x is x squared. X times a minus 2 is a minus 2x. So those are the pieces that you get from distributing the x through. So x times x times negative 2. Then we're going to distribute this 3. And I'm going to distribute kind of underneath so it's not too messy looking. So we're going to take 3 times x, and this 3 is positive, so 3 times x is 3x. And then 3 times negative 2 is negative 6. And so those 2 pieces come from the green distributing. Do you see how you have 4 pieces? Because you had 2 terms times 2 terms. Well, 2 times 2 is 4. So you should always have 4 terms. And it turns out that we can actually combine the middle 2 terms. So x squared is by itself. If you have negative 2x's and you add 3 of them, so this is like you're in the hole $2 and someone gives you $3. Well, then you would just have a single x. And then you have your minus 6. So I believe that's what they would want for their final answer, combine the terms in the middle. But this, where we distributed the x and then we distributed the 3, so I'll say distribute x, that's what we did there, and here was distribute the 3. A lot of you probably learned that as something called FOIL when you multiply, and what that stands for is first, outside, inside, last. And let me explain what the heck that is. So when you have something like x plus 3 times x minus 2, right, that's what we were multiplying. First you multiply the first terms, the x and the x. Then you multiply the outside terms, the x and the negative 2. Then you multiply the inside terms, the 3 and the x. Then you multiply the terms that come last in each piece, the 3 and the minus 2. And that's essentially what we did right there. First, outside, inside, last. It's just a cute little phrase that's supposed to help you remember all 4 pieces so that you don't forget that there should be 4 little products that you get here. But that's called FOIL. That's what I'm going to refer to it as FOIL. But it's just the distributive property. That's all that is.